Welcome back to the Marine Radio Operator Permit class. We're ready for the next lesson. Here's the class agenda. So what we've done so far is we've talked about general definitions. You went ahead and watched the Rescue 21 movie and the GMDSS movie. I hope you found those movies interesting. Hope you're able to take a look at some of those communication systems, fill in some of those gaps if you're not familiar with some of those technologies. And what we're going to do right now is we're going to go into subpart W, the Global Maritime Distress and Safety System. As you can see right there, that's that pillar to the left-hand side of the screen. We're going to talk about all the things that we need to know in GMDSS. Again, we don't need to become GMDSS operator qualified, but the Mrop is the first step in doing so. So we have to become a little bit familiar with just basically some of the terms and some of the technologies. So when is the GMDSS rules and regulations applicable? Look at that. All passenger ships, regardless of size, and cargo ships of 300 tons and upwards. Okay, so all passenger ships, but anything, just like any good CFR regulation, if you don't like what you see, just keep reading. And then you can see in paragraph B, these requirements do not modify the requirements for ships navigating on the Great Lakes or small passenger boats. That's us, the small passenger vessels. So we get a pass of having to be GMDSS certified, both as from the people standpoint, and also the ship and the equipment installed. So again, GMDSS as a whole does not apply to us operating the small passenger vessel industry. However, we just, as the Marine Radio Operator Permit licensee, we need to become familiar with the terms and technologies. As you saw in the movie, there was a whole bunch of different technologies for the ships at sea to talk to each other, to talk to land, both for routine and emergency communications. And again, the whole purpose of GMDSS was designed to automate and improve emergency communications in the maritime industry. EPIRBs, Emergency Position Indicating Radio Beacons. Class 1, what Class 1 means is it's going to float free. So in other words, you can see in that case right there, there's a hydrostatic release. If the ship was to sink, that hydrostatic release would go ahead and release the case, and the EPIRB would float free. The EPIRB would turn itself on and be floating in the water transmitting. The 406 megahertz, what that means is it's a satellite EPIRB. In other words, that signal is being sent from the EPIRB and it's being relayed by a satellite. That's what the 406 megahertz is. Automatic deployment for Class 1. And the batteries. The batteries need to be changed before the expiration date, and there's a little sticker on the EPIRB itself. And also the battery needs to be changed after each emergency use. You register the EPIRB with NOAA, and there's a form right there as an example. You actually do that registration every 2 years. Make sure that the contact information is up to date, and they will go ahead and issue you back a sticker that you go ahead and place on the EPIRB. Search and rescue transponder. You may not be familiar with that one, but you saw it in the movies. And again, what this does is, as a ship is passing by, once you've turned on the SART will distort the returned echo of a marine band radar, and you can see it displays it there as a series of 12 dots, as you can see on the screen. A couple of things you need to be aware of. This operates in the 9 gigahertz marine radar, or the X-band. Why is that important? Okay, all the radars that we use in the small passenger vessel industry are exactly that style radar, the X-band or 9 gigahertz. Okay, the ocean-going vessels, they have 2 different styles of radar. They have the X-band, and they also have a larger band radar that they use while they're in the open ocean. So they have 2 different types of radars, the ocean-going guys, and your SART will only be picked up on the X-band radar. Whereas us in the small passenger vessel industry, the only radar we have is the X-band, so it's not such a big deal for us. A little more detail the movie didn't go into on the SART. The movie talked about the 12 equally spaced dots, and also when you take the FCC exam, they talk about 12 equally spaced dots as they return to the SART. But you as an operator, you should be aware of that. Actually, you can see there on the left-hand side of the screen, when you are farther, 5 nautical miles or farther from the SART, you actually get the 12 dots. But as you get closer, you can see that 1 to 5 nautical mile range, those dots turn into arcs. And then if you're within 1 nautical mile, those arcs would actually be full circles, as you can see there on the right-hand side. So just a little more detail the movie didn't go into. Survival craft station radio. You look at these at the boat show, and they look just like regular handheld radios, but they are not. If they are designated survival craft station radios, they need to meet the following things: operate on channel 16, a minimum output watt of 1 power, minimum power out of 1 watt, minimum effective radiated power of a 1/4 watt. They must have a fixed non-removable antenna, simplex voice only. Okay, that's no big deal there. And then the watertight for 1 meter for 5 minutes. And those are the parameters that the radio system would need to meet to be considered a survival craft station. They get tested to meet those requirements, and actually what it is they're pretty expensive too. You look at it, looks like a little handheld radio, but they're about $600 compared to the $100 that you might pay for the equivalent non-certified radios. The purpose of these radios here, they have a very long battery life, and so you can pack these radios, say in a life raft or something like that, and they're kind of put away, they're on the shelf, and then you break them out in emergency, and you would have the batteries would operate. So you're paying a lot of money for the extra battery system that they have on board. Maritime Safety Information, MSI. Okay, so MSI, what that is, that's all the information that gets transmitted to the mariner. Things like navigation warnings, chart corrections, weather warnings, weather forecasts, distress alerts, ice hazards, all those updates, if you will, that the mariner needs to know about. That general term is called maritime safety information. Now, how you transmit that to maritime safety information to the various ships depends on the radio system you're using. So you can see there's some systems listed there. That's a subset. That's not all of them. But NAVTEX would be one of them, and you saw that in the movie. Think of NAVTEX as basically text messaging over that medium frequency of 518 kilohertz. And those NAVTEX systems are usually standalone systems that receive on only that one frequency, and they receive the NAVTEX messages. If you took that MSI and you broadcast it over an HF system, that's HF narrowband direct printing. Again, you could take the traditional HF radio, receive that signal, and have a printout of some type. And the safety net, again, it's maritime safety information broadcasted over a satellite telephone service. And again, us in the small passenger vessel industry, we may not have all of those systems that it's talked about, but we just need to be a little familiar with them for the purposes of the Mrop exam. We talked about maritime safety information, but how does that MSI get distributed to the various vessels that are out at sea? Well, the way they do that is the world is broken up into 21 navigation areas. And then certain countries are selected as a navigation area coordinator, which will go ahead and collate the information and then broadcast it to the mariners operating in the areas that they're responsible for. As an example, you can see the United States there. The United States is the navigation area coordinator for navigation areas 4 on the East Coast and 12 on the West Coast. So the U.S. go ahead and takes all the MSI information inputs and broadcasts them through the various methods that we just talked about. The NAVTEX, the navigation telex, again, typically a standalone system operating at the 518 kilohertz frequency. It goes ahead and receives that MSI information over that frequency, and it prints it out much like a ticker tape would. There's a couple different styles. This standalone one that we talked about right here in front of you is kind of like the old weather fax machines. So standalone, prints out the information on a continuous piece of paper. But there are some other type of models that we'll look at. So that 518 kilohertz frequency, that's a pretty low frequency, which means that it's going to be a very long-range communication system. And this is designed to be able to send and receive MSI information to about 200 to 400 nautical miles off the coast. So it's a pretty long-range system. It's worldwide, meaning that all the different countries that participate in the program. And if you're receiving that MSI information in the 518 kilohertz frequency, all of that information is going to come through in the English language. Now, there are some other countries that do broadcast the MSI information in their local language, but they would not be using the 518 kilohertz. They might be using something like the 490 kilohertz for their local language transmissions of MSI. So since it is worldwide, how do we break up the world and not copy messages for all over the world in the areas we don't want? We do that with little codes, and you can see there as an example, if you wanted to copy the Netherlands information, you would put in code P, Papa, and copy their information. Once we decide the areas that we want to copy for, we want to also determine what types of message we want to copy. And we do that with another single letter that identifies the type of message that we want to copy. So as an example, if I wanted to copy the meteorological forecast for that particular area, I would want to make sure that I'm copying E-type messages. Let's take a look at what a NAVTEX message and display looks like. On the top there, that text, that's an example of what a message would look like. It looks very similar to the light list updates that we get. In this example here, it's from the Netherlands Coast Guard. It's navigation warning number 9. It has a date time group in August. Platform light number 10, green light. And you can see that the first set of numbers is the latitude, the second set is the longitude, and what it's telling there, unlit. So it's saying that light is extinguished, it's out, and that's how you'd read that message. On the right-hand side, lower right-hand side corner of the page, you can see that's an example of a NAVTEX system that would be PC-based or computer-based. So in other words, you would have a receiver dedicated to the frequency, which would then give that input information into a computer, which is running a NAVTEX style program, and you can sort the messages just like you would sort any other like email style or folder style messages. And on the bottom left-hand side there is again kind of a standalone unit that does a printout and also has a screen on board. Okay, the Maritime Mobile Service Identity Number, MMSI. Now the MMSI, remember we talked about, that is a code, a 9-digit code that identifies your particular vessel through your different communication systems. So if you were a commercial vessel, you would want to get your MMSI issued to you by the FCC. And once you have that 9-digit code, you would plug that into your radios that use digital selective calling. You would use that same MMSI number if you had automated identification systems or AIS on board. You would also use that same AIS for your HF radio if it was digital selective calling enabled. So again, the MMSI is a number you get issued. You put it into your electronic navigation systems, and then the ships that receive your MMSI, they know who they're talking to. There's a lot of information that comes up on the screen of the various different navigation and systems that were used today. Now, if you're a recreational boater, you can get your MMSI issued to you by Boat US or SeaTow. But again, that's just going to be for recreational vessels only operating within the bounds of the United States. You would not want to get your MMSI from one of those, those third-party folks if you plan on sailing internationally. Even if you're a recreational boat and you plan on sailing your boat down to Bermuda or going any place international, you want to get your MMSI issued to you by the FCC. Okay, as always, if there's any questions, give me a call, give me an email. I'll get back to you promptly, and we'll make sure that you get all the answers to the questions that you may have.